Okay, so today we'll be talking about light and color. So first of all, we look into what are the properties of light. So light is able to travel in a straight line, and light is a form of energy. This means that it cannot be created or destroyed. Okay, it must come from one particular source. Generally, the speed of light is 3 times 10 to the power 8 meter per second only in a vacuum. And later on when you see the refraction of light, right, the speed of light would actually be adjusted. It might even be slower or faster depending on the medium, and this will actually result in the refraction of light. Okay, so when light actually hits an object, it can either be reflected or refracted. Now, what is the meaning of these two words? Reflected means that you can see that the light actually is being bounced off through a surface, whereas for refraction is the bending of light. So rather than actually bouncing back up, it actually still penetrates through, and there is actually a slowdown on the speed of light due to the difference in optical density, and therefore you would actually result in the bending of light. So a ray of light is indicated by usually a straight line, and that what happens is one collective light rays will result in a beam of light. So you could always see that light is always straight, it doesn't curve in any way. And at the same time, you will also take a look at the way the arrow, right, will actually indicate the direction of light, and this is very important for light. Okay, so there are actually 3 different scenarios which light can actually move towards to. Divergent meaning the light rays actually move further away from each other, so they tend to spread out from a particular point of source. On the other hand is converging. Converging means you actually move towards a particular point. They move closer to one another. And the other one is definitely just parallel. So parallel, they are just moving side by side. There's no change in the difference in the distance among them. So the one in blue represents the distance in terms of which each of them are in. So the closer it is for convergent, you could see that the height would actually change. It will actually slow down. And for divergent, it will just get further away from one another. So there are different kinds of refraction of light. Reflection of light can exist in 2 main surfaces. The first surface is actually very smooth. So if you have actually a very smooth surface, right, what will happen is you will have very regular reflection, meaning that each of the rays tend to be parallel to one another, as indicated by the color of the highlighted arrow. Second is, if let's say you have actually a very rough surface. What do we mean by rough? Rough meaning your surface is actually quite jagged. This will then result in actually a very scattered kind of reflection, where there is no sense of commonality in terms of direction in which how the light is actually being reflected. So what will this result in? This will actually result in your image form to be very blurry or not sharp at all. Okay, so they tend to be diffused. Now another thing is there is another reflection of light has 2 main identity: incident ray and reflected ray. So incident ray are the ones highlighted in green, where they tend to be the light ray coming towards the surface from a particular source. So this is actually known as your incident ray. On the other hand, the one in yellow is actually known as the reflected ray. And this is where the light ray tends to bounce off through the surface. So you would see that the angle of the incident would tend to be the same as the angle of the reflection. Okay, we will talk more about this at a later chapter. Okay, but over at the diffuse surface, you would see that this angle, they tend to be very different from each other. Okay. Now, There are two laws of reflection. Mainly, number one is that all of the rays must actually lie on the same plane. In this sense, what this actually meant is the incident ray, the reflected ray, as well as the normal must all be touching this plane mirror surface. Okay, so you can see over here, the normal is generally known as the imaginary line that is perpendicular to the plane mirror surface. So this will be our guiding line. Then after that, what will happen? Our incident ray tends to be like what we said, the ray that would be coming from the source to a particular point on the plane mirror, and the reflected ray will tend to come in away from the plane mirror. Angle of incident will be the one of the angle formed from the incident ray to the normal, whereas the angle of reflection will be the angle formed between the normal to the reflected ray. So always take note that the normal tends to be the reference point, and the normal will always be 90 degrees to the plane mirror. And for the second law of reflection is that the angle of incident and the angle of reflection is exactly the same. So this can come as a common MCQ question or structure question where you are required to calculate the angles of incident and reflection. So if we look at over here the scenario, you would see that in order to determine the angle of incident and angle of reflection, you would generally want to first come up with the normal. Do take note that the normal should be dotted, a dotted line, but in this case I will just do a solid line. So imagine this whole thing is 90 degrees. To find the angle of incident, it will be 90 degrees minus 50 degrees to give you 40 degrees. So this is the angle of incident. And because of the law of reflection, the angle of incident will be the same with the angle of reflection. So it will also be 40 degrees. Likewise, in the event of C, first step is to always draw the normal to the plane mirror. So in this case, you will know that this angle here is generally 90 degrees minus 30 degrees, you will get 60 degrees. And since the angle of incident is equal to the angle of reflection, both will be 60 degrees. Okay? So do remember it is 90 degrees to the plane, not to the other plane of mirror where the rays are not intersecting it. Now, the image formed in the plane mirror is due to the reflection of light. So when the light rays, right, are reflected by the mirror, it enters into our eyes, in which the image formed in our eyes, right, they tend to be inverted. And in this case, right, your brain would actually re-switch it back so that it will be actually upright. So the characteristics of an image formed in a plane mirror is in this way, and a virtual image is usually the image that cannot be captured on the screen. Now, what are the steps to actually draw a plane mirror of an image? This one is very important. This is usually an exam question. So the first step is to measure the distance between the two locations, where you first identify where's the object, and based on the object you measure the distance. So they both have the same distance with reference to the plane mirror here. Okay, so in this case, right, if let's say this is 1 cm, the distance of the object to the plane mirror, it should also be 1 cm from the image to the plane mirror. Okay, these two must be dotted line, as solid lines are only drawn for actual light rays. The image should also be dotted, as this is virtual. Okay? Next is to actually connect the image to the length of the eye, to the tail end of the eye. Do take note that this green color area has to be solid line, whereas the area that is orange in color has to be dotted. Why? Because any ray after the plane mirror, behind the plane mirror, they tend to be virtual, so it's not real. Okay, and once you have this, you can denote the arrow. Do take note that light should enter into your eye and not coming out from your eye. Last but not least is to actually join the object to the intersection point of the plane mirror, and this will be the image. Okay, and you are done. Sometimes as a bonus, you may want to also include where the normal is, and through this you will be able to have a complete diagram. Okay, so with this this will be how you actually construct a plane mirror image. You can actually draw and practice this more often so that you'll be familiar with it. This one is a confirm will come out for exam 1. You will need to know how to draw. Okay, so let's say we look at this particular scenario, this particular question whereby you are required to complete the ray diagram. So what's the first thing you can do is you measure the distance. So let's say I measure this distance and through it I realize that the distance is somewhere around here for the image. So how I would want to do it is to denote this as a dotted line. Okay, you must use a ruler to actually denote this. After you have already identified where's the image, you can even draw a circle if you want. Okay. The second step is to actually identify where your eyes is. So I will assume your eye will be somewhere here. Now, because over here they have already drawn the reflected area of the object, right? So you do not need to know that this would have to be intersected to the image form. So what you can do, you just have to extend it further. Another check you can do is that when you draw the normal, the angle of reflected should be the same with the angle of incident. And then you can eventually find the position of the eye. This is still not completed. What you need to do is to actually add in the arrows as well. And do draw the correct arrow sign, as arrows indicates the direction and it's worth at least 1 mark. Okay. There are many different types of mirror. You have the plane mirror, which tends to be very, very smooth, and at the same time it's actually straight or flush horizontally to the ground or to the table. The convex mirror, on the other hand, actually has a curvature, whereas a concave also has a curvature, but it actually concaves merge inside. So in other words, your concave would have bounce inside, whereas for convex they tend to bounce outside. So they have different applications. For one, for mirror, when you have a plane mirror, they tend to actually have like for decorative purpose, or even to actually be able to use to look at areas which you can't see through reflection, like the plane, like the periscope in a submarine. Okay, if you want to have a convex mirror, you tend to actually want to see things behind a band, or to actually have a wider field of view or vision. Okay, then of course, if you want to actually magnify a particular small object to something big for you to see, you will use a concave mirror. So things are like your microscope, your dentist mirror are areas to enlarge on certain on the image form. Okay. So over here, due to the difference in the angle of incident and reflection, this helps to actually enlarge the size or the field of view of the image form, and therefore it gives actually more of like a wider a form of wider magnification, or even a wider field of view for your eyes to actually see. Okay, so these are some of the things to take note of. Next, we look at refraction. So just now we have talked about reflection, whereby it's the bouncing of light. Now it's more of like how is light actually reflected across a medium. So in this case, refraction, right, is actually the bending of light. Refraction is actually the bending of light rays when they actually travel from one transparent medium to another. And these two medium, they tend to be of different optical density. Okay, so what will this result in? The difference in medium, right, will actually result in a change in speed of light, and therefore it results to the slowing down of light or the speeding up of light. But do note that the maximum light can actually travel is 3 times 10 to the power of 8 in a vacuum. So the light will actually, when they actually slow down, they tend to actually bend away or towards the normal. Okay, we'll discuss more. So in a sense, refraction of light can only take place in a transparent medium such as air, water, vacuum, glass, or even diamond. So things that are opaque in nature, like a cardboard or wood, right, there will not be a refraction of light because light cannot actually pass through it. So light travels at different speed in different medium, where having a less optical density medium, the speed of light tends to be faster. In a denser medium, the speed of light is slower. So how is it so? So if we look at let's say you have a box, and inside has a lot of maybe particles clouding it. This will then result in actually the box having a higher optical density. And in this case, when light actually penetrates through it, you could see that there is a lot of resistance to move into it. It tends to slow down. It's like your particles are forcing it to actually slow it down even further. This will then result in your light, right, to bend towards the normal. So imagine, rather than it actually supposed to move in a straight line, the light actually curves towards the side. Okay, and this will then of course be due to the difference in optical density. When you compare air, which has maybe a lesser optical density, you have only a few particles floating around, and this blue color can be a glass block or water in this sense. However, if let's say you are from a very high density area, which is like for example from here, and suddenly you are pushing it outwards, you could see that your light will be able to move faster, and this will actually result in light moving towards the normal. Okay, so these are some of the things to take note of. So in a nutshell, this is how it looks like, where light will actually bend towards the normal. The normal is this imaginary 90 degrees line. So you could see that as you're moving from a less optical denser medium to a higher denser optical denser medium, they tend to the reflected light ray will tend to move towards the normal. While on the other hand, you are from a denser medium moving to a less dense medium, the ray will tend to move away from the normal. Okay, so in this case, let's say we have this red color line to be the imaginary line. In the event that it's of the same optical density, then you will move straight, right? There will not be much bending of light. So from this, you could actually see how much it actually bends away. Okay, so these are some things to take note of. This one very important. Please remember for exam. You will be asked to draw a graph like this. Sometimes this graph can be in the form of a box, not a line. So it can be something like this. Then you are required to actually draw how it actually bend towards. Okay. Next, we look into reflective index. Reflective index is not really needed for most of your papers, but generally reflective index helps to measure the ratio of the bending of light when traveling from one medium to another medium. So in a way, how do you calculate this? It's just reflective index is a number. There's no units for it. It's sine I over sine R. Now, what is this I and what is this R? This I is the angle of incident. And this R is the angle of reflection. So in this case, you would see that the I would be somewhere here and the R would be over at the other side. So do take note that the angle will always be measured according to the respective rays to the normal. Okay, and the value here will actually share with you what is the how much is it actually will actually bend towards or away from the normal. Now next thing is, in the event that light ray is not shine at a angle, instead it's actually shine 90 degrees, it's aligned directly to the it's parallel to the normal, then how so? There will not be any reflection of light, it will just go straight downwards. Okay, and in the event that both medium A and B, they have the same density, the light will actually not bend at all, it will just move in a straight way, in a straight motion. Now, what are some effects of refraction? Effects of refraction will lead to the two concepts, which is apparent depth and real depth. So for apparent depth is mainly how you perceive the it's like your eyes are playing a trick for you on you lah, that you may see it's actually not really the actual depth, but what your eye is actually perceiving the depth is like. So it's like a fake kind of depth, whereas real depth is the actual depth of the particular object. Okay, so real depth is the actual depth. Apparent depth is the depth perceived by the observer. That means a feeling based on what you see. So for example, you may want to see that the fish is actually, so let's say the fish is actually the object and is swimming over in this area. Due to the bending of light, right? Because the light ray doesn't come from your eye, instead it comes from the source. So what will happen is you are moving from a optically denser medium to a less dense medium. So in a sense, what will happen is this light ray, right, will result in a bending of light. It will bend away from the normal. The normal is over here. And what will happen? The image is actually formed through the straight line of the reflected ray. And that's why the image will always appear above the object. So this itself is the actual depth of the object to the surface of the water. Whereas when you are talking about apparent depth, it will be the distance from the image to the surface of the water. And do take note that the image tends to be virtual. Okay? And we will take a break from here. The next part we will actually be covering color.